And good morning. On behalf of QCrete Ready-Mix Concrete Private Limited, I am Kaushik, speaking on this Saturday on the subject of blending more SCMs for better concrete. And QCrete Ready-Mix Private Limited has been conducting webinars, and this is 30th in this series. And I am thankful to our MD, Mr. Shalif Fernandez, for giving this opportunity to speak on this Saturday. And I also thank all the participants to have come to listen to me on this Saturday. SCMs, as we know, are also called as pozzoling materials. First time found in a village called Pozzoli, Italy. SCMs are also called as mineral admixtures, as their compositions are mineralic in nature. They are also called as supplementary cementitious materials, and they have attained a wide role in production of high quality concrete throughout the globe. It is not that the SCMs have been used now. There are evidences that Romans used fly ash, a kind of volcanic ash, with seawater to make mortars and construct big buildings like Roman colosseums. There are evidences for such highly durable mortars being made long time ago in many places across the globe using lime and volcanic ash and things like that. Use of SCMs have attained significant significance over a period of time because of the benefits they pass on technically, economically, and environmentally. What benefits they pass in each of these areas, he has made the SCMs a kind of almost part and parcel of modern day durable concretes. Fly ash has been being used in concrete from 1930s, and different levels of fly ash contents have been chosen to use in different kinds of concretes, and the applications have been classified into low, moderate, high, very high. Applications of these materials have been found to be classified as, if it is less than 15%, very low, and if it is 30 to 50%, it is high, and very high levels of usage of fly ash. And in this lecture, I'm going to concentrate more on fly ash. Even though in many parts of India we use GGBS, and GGBS is abundantly used, that is also another material. I'm in this webinar, I'm trying to concentrate more on usages of fly ash, especially at higher volumes. So for a long time, at different dosages, fly ash has been used across the globe and also in India. Ready-mix concretes, especially ready-mix concrete manufacturers, started incorporating fly ash in very big way in the year 1998, around 2000 in India. And earlier to that one, ready-mix companies, many ready-mix companies, even after that, started using fly ash, but they were not showing the usage of fly ash openly on their invoices and batch records. And there is a shift, means paradigm shift after 2000, where some ready-mix companies took step forward and they started mentioning on their invoice and educating the customers, building the awareness in the customers about the benefits of fly ash. So in India, generally, fly ash concretes have been made with up to 35 or lesser than 35%, with some also examples we will give later. We'll talk about high volume fly ash in India also. Most of the concrete technologies know that fly ash comes from thermal power plant, and here, as everybody knows who are using fly ash, it is stored in different silos after being collected through electrostatic precipitators, and the coarser fly ash is dumped actually, and the finer fly ash is preferred and used in concrete actually. Finer the fly ash, better its performance, because it is found that fly ashes which have particle size between say 5 to 30 microns have been found very effective for making good concrete. Fly ash particles which are of higher diameter, thicker, coarser than 45 microns tend to give very low reactivity, and hence such particles, thicker particles of fly ash, may sit as dummy particles in the body of concrete and hence not preferred. So when somebody is receiving fly ash as a concrete producer, it becomes mandatory to check for the quality of fly ash. Even though they could not do, means we cannot do all the tests. Actually, the basic tests that have to be done is 45 microns test, 45 microns CU test, where the limit has been set as anything, the residue on 45 microns, if it is more than 34%, then the fly ash stands to be rejected. Means it represents that coarser particles are not required and it will be acting as filler material, and we have to be very careful on this actually, because the biggest challenge for concrete industry in India is there are very minimum number of classified fly ash suppliers. Whatever has been collected in the silos in thermal power plant is brought to ready-mix companies, cement companies, concrete producers, and being pumped and dumped into the concrete manufacturers' yards. The onus of usage of fly ash completely rests with the concrete producer. The QAQC related to fly ash usage completely is the responsibility of the concrete producer. There is no guarantee from the suppliers, because most of the suppliers, barring a very few numbers in India, they don't take the responsibility because they say that whatever fly ash has been there in these silos, storage silos of thermal power plant, it is being transported and given to the ready-mix companies, and they don't have any role in that. They're just their transporters bringing from thermal power plant to the ready-mix companies or concrete producing yards. So we need to be careful about this particular aspect, and this is the single most important point actually, which determines the quality of concrete that is going to be produced by using fly ash. The beauty of fly ash is its spherical particles when you look at a microscopic level, which the sphericity of these particles give the workability a jump or a boost when you are using fly ash concrete. That is why these fly ash particles act like ball bearings. They move over each other, and it produces a better mix actually. Because of the sphericity of these particles only, whenever we are making a conversion of a OPC mix to a OPC plus PFA mix, you can straight away expect a water reduction of about 6% to 8% if you are using a replacement level of about 25%. So that kind of water reduction is possible when you are replacing a ordinary Portland cement mix with a fly ash mix because of the spherical nature of the particles. All fly ashes are same? No, all fly ashes are not same. And there is a specific classification where, based on the amount of CaO and based on this SiO2, Al2O3 plus Fe2O3 content, there is a separate classification for class F and class C fly ashes. Class F fly ashes generally contain very low amount of CaO, generally up to 5% or maximum 8%, something like that. And above that, CaO content is more. When the CaO content is more and the combination of SiO2, Al2O3, Fe2O3 content is slightly more than 50% and not more than 70%, such fly ashes are called class C fly ashes. In India, class F fly ash is predominantly available. Class C is not available to that extent actually across India in many thermal power plants. Very few thermal power plants give this class C fly ash. So, as we discussed earlier, the SCM and Canadian specification also classifies like this actually. When it is less than 8%, it is CaO, and then between when the CaO is 8 to 20%, it is class CI, and class CH is when the percentage of CaO is more than 20%. So many times, based on the coal available, based on the efficiency in way how, by which it is burned and how they are collected, everything, the classification now, as we are seeing here, the Canadian standards classification, we can see different types of fly ashes, but generally it is class F and class C. So when it is class F, they are said to be pozzolanic in nature, more pozzolanic in nature. When it is class C, means when the dominance of CaO, when the CaO content increases, such materials, such fly ashes are classified as class C, and they are both pozzolanic and hydraulic in nature. Okay, now you can see most of the Indian fly ashes fall into this category type F here. They come in the topmost left hand corner here, and very rarely some fly ashes come here, which is Canadian standards type CI, and we don't get we are very rare to get this one actually. Okay. Now, as we discussed earlier, the sphericity of the particles give a distinct advantage when we are using OPC plus fly ash mixes actually. When you are replacing OPC with fly ash, as we said, the water demand goes down. That is one of the distinct features of usage of fly ash. And here in this graph, you can see the free water content going down when you are increasing the fly ash content actually. As you are increasing the fly ash content, your free water content required to produce a certain slump or workability reduces. And here you can see when the fly ash particles are thicker and thicker in size, thicker and thicker, then the water demand will be more. When the fly ash particles are finer, then you come to the left hand side here where your free water content reduces. So it is thumb rule that when you are changing a OPC mix to OPC PFM mix, you have to reduce the water content actually. There are some people, some scientists, some people who just want to do the trials, use the concrete as though they are using OPC mix. It is not going to work like that actually. Whenever you are converting an OPC mix to OPC PFM mix, the first principle, most important principle you need to remember is that we need to reduce the water content to get something closer to original strength actually. If you really want to match the strength of the controlled concrete, that is OPC concrete, you need to increase the cementitious content. For example, if you are using a 300 kg mix, you need to increase the cementitious content mix to 330 or 340. Then you replace with certain amount of fly ash. The replacement of level of fly ash depends upon the application, but we cannot try. For example, you cannot compare 300 kg OPC mix with 300 kg OPC plus fly ash mix. Naturally, you are going to get a lesser strength, unless otherwise you go down the water cement ratio significantly. One of the problems that is encountered while using fly ash is the particular factor loss on ignition, and it represents unburnt carbon particles actually. The characteristic of this higher LOI is it increases the water demand. It increases the water demand for a similar mix or similar slump actually. And if the water demand increases, then alternatively, to keep a lower water demand or to control the water demand, you need to use more chemical admixture. And this becomes a bigger problem if you are using an air entrainment admixture. To have similar air entrainment levels, you need to use higher amount of air entrainment admixture. So LOI is a very important indication on the quality of fly ash that we use. We need to preferably use LOI as low as possible. Lower the LOI, better it is for the concrete. Now, moving on to the other things that, for example, one of the significant impacts that fly ash concretes make is a reduction in the heat of hydration that they produce when blended with OPC mixes. Especially useful when you are using mass foundations, huge concretes, thicker concrete. In such situations where the temperature has to be control, you need to blend certain amount of fly ash, and you can see here effect of fly ash and temperature on the penetration resistance or the compressive strength actually. And as the penetration resistance to increase, you need to have lesser amount of fly ash. If you go towards higher dosages of fly ash, the penetration resistance will be lesser. This is what we are talking about, the effect of fly ash on temperature rise, especially when you are using thicker foundations. As we discussed earlier, the temperature at core has to be controlled. Core temperature has to be kept to as minimum as possible, and the difference in temperature between the core temperature of concrete and the surface temperature has to be less than 15 degrees. To control that one, if you just use OPC, then the temperature rise will be very high. To control that one, heat of hydration, we can use fly ash concrete. You can blend fly ash in certain percentages to reduce the heat of hydration. So if you are using a class C fly ash, you can see here in 7 days without fly ash, you have high amount of temperature heat generated actually. And when you are using high volume fly ash, when you are blended up to 40%, 56% here, you can see the amount of heat is reduced, and hence you have durable concrete because thermal cracks don't take place. Cracks are reduced in the body of concrete. So this is one of the major benefits that is fast when you are using fly ash, especially if you are shifting from lower amount of fly ash to higher amount of fly ash. So this is another table which substantiates the usage of more and more fly ash. You can see here 180 kg OPC and 220 kg fly ash. It gives 54 degrees as the maximum temperature against 83 degrees as maximum temperature when OPC mix is used. Why we go on telling to our customers to reduce the OPC and blend OPC with fly ash or GGBS is because of this very important reason, that the amount of heat generated in the body of concrete is kept to minimum and controlled. That is the reason we always say that you blend some amount of fly ash or GGBS to control the heat of hydration. So this is particularly important in mass foundations, and when you are making high volume fly ash concrete, like as per this example 180 kg OPC and 220 kg fly ash with a very low water cement ratio, to have contained, you have got the maximum temperature 54 degrees, but that temperature has been attained slowly. It is not a quick rapid rise in temperature which is harmful to the concrete. The rise of temperature is slow, controlled, and hence this has a very good benefit on the durability of mass concretes and foundations. Again, some more examples have been given here where we have used type 1. Type 1 is OPC 53 grade, similar to that one, OPC 43 grades. And you can see here 125, 155. Okay. And the amount of heat generated is 54 degrees, which is significantly lesser when compared to the control concrete. So if you are making huge concrete structures, large mass foundations, it is necessary to blend high amount of OPC plus fly ash. Alternatively, you can go for OPC plus GGBS. Worldwide, for mass foundations, raft foundations, the specification is 70% GGBS, 30% of OPC. For the same reason, what is shown here, either you can do with fly ash or you can do with GGBS and achieve the similar control on the heat generated. Why should we use fly ash and why should we use more fly ash? The answer is given by this graph actually. So for a customer who purchases concrete, say M25, the strength gain will be continuous for him when he is using OPC fly ash mix or OPC GGBS mix. And as we are blending more and more, for example, here in this curve, you can see the OPC mix where the curve has almost become parallel to the x-axis. The OPC mix, as it is aging, is not showing any big jump in terms of strength actually. Whereas when you are blending fly ash, the strength gain is lower in the initial stages as represented in this graph, and you can see this gap. You can see this gap that after 28 days or after a certain period, it is taking off and going higher and higher. And you can see this strength gain continuously. Some people have observed for 10 years, some people have observed for 20 years, some people generally observe for 90 days. You can always see a significant strength gain over a period of time. This is the significant advantage, and I can say one of the most important aspects when you are using fly ash. And it is very, very important to consider this when you are making big monuments, public buildings, structures which are of importance, where you can specify later age strengths. Actually, there are other countries other than India where they have started specifying 90-day strengths, 180-day strengths, 56-day strengths, where in such cases you can proportion your mix with a lesser amount of OPC and higher amount of fly ash or probably GGBS, where you will have long-term strengths and you can utilize that long-term strength benefit given by SCMs. This is again another set of graphs made where you can see here as the days are passing, standard laboratory theory, in a laboratory condition this has been done, where you can see the 3C curve is flattening after some time. It is flattening after some time. Somewhere after 28 days it is becoming flatter, but when you are using fly ash concrete it is going further and further, higher and higher. The other graph also shows similar picture where a OPC mix is overtaken by fly ash concrete mix as the aging is taking place. As I said earlier, even if, for example, a concrete mixture, for example, M25 gives just, it touches the characteristic strength 25 newtons per mm square in 28 days. Even though some set of these kind of tubes may slightly be questioned as per IS criteria for passing, it is certain that just if it touches even the characteristic strength in 28 days, you can expect maybe 10 to 15 MPa up to 90 days after 28 days. An increase, you can expect 8 to 15 MPa between 28 days to 90 days, depending upon the mineralogical characteristics and the interaction between OPC and fly ash. So even if the concretes are touching just characteristics, then you are assured and ensured that you have very high strengths at later ages. But on the other hand, let us say you have used a OPC mix and let us say it has just barely touched the characteristics. There is no guarantee that that kind of concretes will improve in strength over a period of time. Then you have a question mark on such concretes actually. So it is always good to blend OPC plus fly ash or OPC plus GGBS mixes in your projects, and definitely OPC plus fly ash. If you are blending more than 35%, it will be a huge benefit actually. Even though the IS code specifies 35%, there are concretes made worldwide. We'll come to that one later, where you have used higher grades of concrete for harnessing the benefits of fly ash. Personally, one of the most striking fact, you can say, that can be extracted from the usage of fly ash is its significant impact on the chloride and permeability. So whenever we blend fly ash, good amount of fly ash, you can see resistance to chlorides significantly improves actually. You can see here the RCPT value as measured by C1202, where the OPC mix with a water cement ratio of 0.4 stands here in terms of coulombs, and if the coulombs value is 2000 and above, that concrete is not a very good concrete. It can be classified as a simple ordinary concrete, and when it moves down below 2000, especially as it is moving downwards around 100, around 500, such concretes are can be classified as excellent in terms of performance against chloride and ingress. So one of the ways of containing the chloride and ingress and giving a significant resistance to concretes is by incorporation of good amounts of fly ash or GGBS. Here you can see a 56% fly ash and 44% fly ash. This triangle and this rhombus represents that as it is aging more than 3 years, it is touching a very low value of RCPT, which emphasizes its extraordinary performance against chloride and ingress, indirectly representing extraordinary corrosion resistance and durability. So the durability of such concretes is extraordinary. So if you want to do concretes, especially marine structures, concrete structures touching water in saline environment, we need to go for this kind of either OPC plus fly ash or OPC plus GGBS. And here we are talking about fly ash. When we are blending above 40%, there is a significant decrease in the chloride and ingress levels, and it is pushing the concrete to higher level of durability. You can see here a data of cores taken from 10-year-old concrete blocks, and a stunning result is depicted here actually, where a high volume fly ash concrete at about 57%, the RCPT value is 0. That means no ingress of chloride ions even after 10 years. Means it shows a huge leap in terms of making the concrete durable. So there is no way we can avoid high volume fly ash concrete or high volume GGBS concrete for such applications where the RCPT value is a primary criteria for durability of structures actually. So this also represents the permeability of concrete, and you can see here from the field cores have been taken after 10 years, and you can see the Portland cement stands at 380. Okay, and there is a huge shift. It has been nullified actually, means the RCPT value is 0 here, and you can also see this 57% fly ash is competing almost with microsilica in terms of RCPT value. One more table depicting the same. Actually, you can see a huge impact on the RCPT value. After 7 years, you can see it is less than 100, and hence the concrete is, you can say, ultra durable concrete. It is a very highly durable concrete. Again, coming back to OPC concrete, there is no way OPC concrete can match the fly ash concrete or GGBS concrete. Okay, so here you can see at a depth of, for example, 10 mm, at a depth of 10 mm, you can see good amount of chloride ingress in as the days are passing, and we can see here that after 4 years, on a M35 concrete OPC mix, you have at 10 mm more than 1.5% of chloride being percolated down. Okay, and on the other hand, you can see another graph which shows that at about 30 mm depth, you have a concrete which is having huge amount of chloride and ingress, approximately about 3.5 or 3.6% of chloride mass, which has entered into the body of concrete at about 30 mm depth actually. So OPC concrete mixtures fail miserably in chloride and ingress test actually, and should never be recommended actually. So on the other hand, when you are touching a 21 to 26 mm depth, okay, even in the initial ages, let us say we go to 30% and 50% fly ash concretes, 30% to 50% fly ash concretes. Even in the initial days, the chloride penetration is lesser. You can see here it is negligible, almost touching the x-axis when you are blending about 50% of fly ash. And as far as the dimensional stability of concrete is concerned, we have, when you are blending class C fly ash up to 20%, the expansion is negligible, and when you are blending higher amount of percentages, the expansion is slightly more. Again, it depicts that even when you are blending in moderate quantities, the fly ashes have good durability as far as the expansion is concerned. Again, this depicts effect of fly ash composition on the level of replacement on expansion of concrete, and as we are going towards higher and higher percentages, which is the subject of the day, the expansion is lesser and the stability of concrete is better, durability of concrete is better. One of the points raised against usage of fly ash, especially usage of high doses of fly ash in the concrete, is carbonation. So if we look at this table, actually, if you are going towards a M30 concrete, the moist curing, when you are talking about moist curing for 7 days, if you are touching a 30% or 50% fly ash, the carbonation is increased, you can see. But how to counter this, how to make this concrete usable, user friendly for us? Actually, the carbonation level can be controlled by providing a thicker cover. A 40 mm thick cover is recommended, actually. And also the carbonation is said to be not a important point when you are significantly reducing the water cement ratio and making a concrete of a higher grade. At later ages, the concretes can either give similar concrete carbonation levels similar to control or better reach over a period of time, so it is not a problem. So if you are blending higher amount of fly ash concretes, one of the most important things that we need to do is reduce the water cement ratio and go for slightly higher grade of concrete, at least which can give higher grades of concrete at later ages to have comparable carbonation levels. So in short, carbonation will not be a problem if you are controlling the water cement ratio to a very lower level and then aiming for a better strength concrete. So with and without Portland cement concrete and high volume fly ash concrete, actually there is no serious damage done. Now we just go through the properties of fly ash, how it affects, especially when we are moving from a normal amount of fly ash to higher levels. What happens? Fresh concrete, if you are talking about, workability is always improved. We already discussed, because of this sphericity of the particles, there is a significant improvement in pumpability, placeability, bleeding is reduced, and it also gives a guidance that you have to, when you are reducing the when you are converting an OPC mix to a fly ash mix, you have to reduce the water cement ratio, say by 3% to 10%. I would also say that the water cement ratio goes down in the descending order from OPC mix to OPC fly ash, OPC GGBS mix, and then to OPC fly ash mix. OPC fly ash mixes have to be produced with the lowest level of water cement ratios, because naturally the workability is best with fly ash mixes. Setting time when we are talking about fly ash is extended. It helps the concrete producer or a concrete manufacturer to transport the concrete, place the concrete, pump the concrete for longer time. But we need to be careful in the cold weather conditions on the rainy season or during very low temperature seasons like in winters. Actually, heat evaporations, fly ash concretes have good effect on heat evaporation. It reduces. So class F fly ash is preferred, actually, and you have to use in high levels these materials to combat the temperature rise when compared to control concrete, that is OPC concrete. You cannot have high early age strength when you are using OPC fly ash unless otherwise you shift to lower replacement levels, or you use certain modern day admixtures to get early age strength. You may have to use accelerating admixtures, or you may have to use materials like silica fume or such additions to gain early strength. Long-term strengths, we have a lot of experience in measuring the long-term strengths across India, and in several ready-mix plants we have taken continuously made studies on long-term strengths, and sometimes the long-term strengths are such that it has almost improved by 80% over control at 28 days when we have used fly ash concretes. Means a concrete which was about 30 newtons in 28 days has resulted in a 55 MPa concrete in 1 year. So long terms are significantly better. So worldwide, people who are very conscious about reducing the amount of OPC have been slowly shifting to 56 days and 90 days strengths actually. Permeability and chloride resistance is significantly reduced, and this is one of the winning parameters against OPC mixes. Expansion due to alkali silica reaction is controlled, reduced. Sulfate resistance sometimes increased by class of fly ashes, and there is a specific instruction to avoid class C fly ash. Of course, we don't get more of class C fly ash in India. Carbonation we already discussed actually. If you are using higher and higher amount of fly ash, we need to be very careful, unless otherwise we take care of the mix design, and also we need to take care of the amount of water that we put in. And you want to do a very highly durable concrete matching the performance in carbonation, you need to go down to a very low level of water cement ratios like 0.3 or 0.32, something like that, and then increase the cover. Cover has to be taken care. Cover is very important. A 40 mm cover is recommended when you're using high volume fly ash concrete. There are many structures built around the world with high volume fly ash concrete, especially dams where you need lakhs and lakhs of cubic meters of concrete to be placed. And the other aspect why we have to use high volume fly ash concrete for making concrete for dams is that you use also bigger aggregates, 150 mm, 80 mm, that's such kind of bigger aggregates you use, and you need to keep the concrete pumpable condition or cohesive condition. In that case, you need to, for keeping the concrete more cohesive, least bleeding, you use fly ash concrete in such cases. So fly ash concrete has been used around the world. High volume fly ash concretes I'm talking about has been used for tunnels and buildings. There are specific cases where for M30 concrete, the specification has been given as 56 to 90 days. Strength should be 30 in 56 days and 40 in 90 days. So such concretes have been 180 OPC, 220 fly ash has been used in America for building many hotels. Actually, they have built such hotels in 1980 itself. And some of the mixture proportions here has been given, which is 150 150 OPC 150 fly ash 150 170 170 for M30 concrete. Actually, you can see here the water cement ratio, they are very low actually, that has to be maintained. And as we have already discussed, the strength development is, if you take a normal concrete, 30 MPa concrete, it is on the lower side, it will not increase after some time. But when you are using a 50% fly ash mix, it improves significantly. That is a very, very important point which we have discussed already. So what are the percentages that you have to use for different members? A guideline is given actually, and a water cement ratio guideline is also given. So wherever thick structures are there, footings are there, you can go up to 43 or 50%, and then you can reduce as we go higher. So many buildings, as we talked about, has been built using high volume fly ash concrete, and in India, concretes have been made, roads have been made. For example, Rupar, Punjab, Gurchandar, Maharashtra, Rajkot, they have used 225 OPC, 225 fly ash with water cement ratio with between 0.33 to 0.35 with SNF, sulfonated naphthalene formaldehyde based mixture, and they have been found to be okay even after 15 to 20 years. So such payments have already been tested, used in India. Again, compressor strength, you can see here over a period of time what happens if you are using 0% fly ash, and what happens when you move up as your fly ash content is going up. You can see the curve is moving higher and higher, and even you have internal curing compound incorporated in fly ash mixes actually to facilitate better curing and for better strengths. You can see here when fly ash has been used at 60% and internal curing compound has been used to give a better strength. You can see this inverted triangle. So not only in India, as I said, worldwide pavement concretes have been made with 44% fly ash also. Here you can see the 90-day strengths overtaking the control concrete, overtaking completely the control concrete, and resistance to chlorides, absorption for permeability has increased, resistance to abrasion. Resistance to abrasion when you are using fly ash concrete initially is lower. As you cure more, you take care of the concrete in the initial days. Slowly, the abrasion resistance will not be a problem over a period of time. So everybody is happy that okay, we'll use high volume fly ash concrete. Many people think yes, we can use, but we need to take care of certain points. Actually, we need to observe and we need to control certain things. Actually, water cement ratio, as I said, as a thumb rule, whenever you are using fly ash concrete, your water cement ratio has to be lower and lower. Keep the water cement ratio at the lowest level. We know that the OPC controls the setting time in a concrete mixture when you are using OPC fly ash or OPC plus GGBS. So higher the amount of OPC, quicker is the setting of concrete. If you reduce the OPC and increase the fly ash content, the setting time increases. So we need to be aware of this one. Just like we cannot treat the OPC fly ash concrete, especially the high volume fly ash concrete or more blended concrete, in the same way, we need to give time. The concretes will take more time to set actually. The de-shuttering time will be more. So we have to have some patience regarding that one. And curing time is very, very important. We need to, as the reactions are slower, to realize the full potential. To realize the full potential of such concrete mixtures made with good amount of fly ash, you need to cure more and more. As you cure more, you are giving an opportunity for concrete to gain strength more and more, and the potential strength will be reached. And even beyond the 28 days, the strength will continue to gain. So we need to cure the concrete with OPC fly ash, especially OPC plus more fly ash, as long as possible. The important aspect in mix design, there are no specific mix design procedures when you are making high volume fly ash concrete. Whenever you are blending OPC with fly ash, as you increase the fly ash content, you need to automatically take care of your sand content. You cannot keep the same sand content. You can reduce the sand content, because otherwise the paste volume go on increasing actually. And then I have told already many times, when we are increasing the fly ash content, or if you are increasing the GGBS content, our water content or water cement ratio should be going down and down. Before going to full scale production, study both fresh and hardened properties. Admixture role is very important. Sometimes you find incompatibility with OPC PFA system, and setting times may be delayed, and therefore we need to do full scale laboratory studies before we take it on the field. More curing periods and internal curing compounds can be used to enhance high volume fly ash concrete performance over long periods of time scale. High volume fly ash concretes are blended concretes with higher amount of fly ash. There is significant improvement in workability, pumpability, placeability. Bleeding is controlled, bleeding is negligible. And then once the bleeding is controlled, segregation is controlled, the tendency to crack will be reduced. Cracks, plastic shrinkage, plastic settlement cracks will be reduced, provided we cure properly. The curing has to be taken care. High volume fly ash concrete or more blended concretes have very good applications in SCC and free flow concretes and such concretes. Setting time, we need to be careful, and we can use modern day PC based admixtures combined with accelerators to control or manage the setting time delays. Later resistance are improved, RCPT values are better, heat of hydration is better. Thermal properties, high volume fly ash concretes is said to have better thermal properties, said to have slightly better insulating properties when compared to normal concretes. Resistance to sulfates is better, but if you are completely going higher and higher, at certain stage the sulfate resistance will be something closer to controlled concrete. Overall, the blended mixes with high amount of SCMs gives improved durability, and with this I also just want to throw some light on high amount of usage of GGBS in concrete. Worldwide, the specification for highly durable concrete against chloride ingress and resistance to sulfates is high volume, medium volume to high volume fly ash concrete. Or you can also shift to OPC plus GGBS. OPC is GGBS with higher volume, 70% of GGBS, 30% of OPC is recommended for control of heat of hydration, especially in mass foundations, draft foundations. And OPC GGBS at high levels of GGBS is also recommended for marine structures. And in all the parameters, creep, drain shrinkage, everywhere, blended concretes, both at low to medium to high levels, either match the performance with the control concrete or exceed the performance control concrete. And we should be very careful to understand that whenever we are blending high amount of fly ash concretes or GGBS concrete, we are discouraging the usage of OPC, and hence we are indirectly promoting a greener concrete, and we are giving a better concrete to the world, which can make the world greener and cooler. Any questions are there? You can ask, or later on also you can send the questions to me. Anybody has questions, they can send it to me, or you can ask now itself. You
Hello. Hello.
any questions from any of the participants? Yes, 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 madam.
I am Rajni, structural engineer. Hello. I have a
Hello.
question. Hello. I have a question.
Yes,
Yeah.
yes.
Whether I should be used in ready mix concrete only, or it can be used for manual mixing also?
Madam, can you type it, and can you type it? I am not able to hear properly.
Okay. Okay.
If you can type and send it, that will be better.
Okay. I'll send you to your mails. Okay.
I'm thankful to all the participants on this Saturday for spending time on this QCrete webinar number 30. And I'm also thankful to QCrete Ready-Mix management, especially our MD, Mr. Ali Fernandez, for giving us an opportunity to make this webinar. As we are promoting the concepts of concrete, many technical matters are being discussed actually. This is our 30th webinar, and I'm thankful to all the participants once again on this Saturday. Thank you.